The first session after lunch with Matteo. He's Italian. Now, I'm not going to stereotype, right? But you know that all Italians live with their moms and all this stuff. He's going to prove that that's not true. Yes, exactly. By talking about his grandma instead of ma. Kind of like he's definitely not stereotypical. Okay, let's go. Talk about eBPF. Something.
Yes. Perfect. Amazing. So as Victor said, this is not a stereotype. I used to live with my mom until I was 18, actually, so I moved out very early. But my grandma was actually like the one that brought me up, because my mom was working, and of course, you gotta stay with your grandma, cooking great food, by the way. Yeah. And today we're gonna not talk about food, I mean, somewhat, yes, I'm gonna mention some food, but we're gonna talk about eBPF. First of all, hello everyone, I'm Matteo. For the ones that don't know me, most of you actually, I have just some friendly faces that I recognize. I'm a CNCF ambassador. Recently, I just joined. I'm a Kubernetes contributor. I'm leading comms for 1.32. So if the blog has some mistakes or like non-correct stuff, it's me. I'm a KCD organizer in the Netherlands. So we do Kubernetes stuff and meetups also. And above all, I'm a metal singer. I think you can guess it by the outfit. And that is me when I had like long hair. I still have a band, by the way, in the Netherlands. It's called Scapegoat. We're going to go out in 2025. This is just a shameless plug for my music, you know. You got to do some marketing, man. Let's start with some fun facts. Do you recognize this flag? Anyone? Yeah? Yeah? Okay. So when I landed in this country, in this state, I should say, I saw this flag, and I was like, what the hell is that? I have no idea. I looked it up, and apparently Utah is called the beehive state. And it's funny, because we are talking about bees and eBPF. So that's a fun fact. It's called the beehive state because I guess a lot of people are like working towards the same goal. It's a very like cute thing. And today we're going to work towards understanding eBPF together. Now, once upon a time, I gave no talks until like the first rejects in Paris, like my first rejects in Paris. And since then, I never stopped talking. So as an Italian, moving my hands all the way. So I have to thank all the rejects organizers because they gave me the opportunity to start my like public speaking career, I would say. And I even got a job out of it, so pretty cool of them. And now enough with the trivia. We're going to start with some bees. What do I know about eBPF? Well, I played mainly in production with some of the common eBPF tools, principally with Falco and Cilium for security and networking, but also KubeArmor and Calico. I never really understood what was going on under the hood. Like, I'm one of these people just reading the documentation and the getting started part of the documentation, trying it out. Does it work? Does it do what I have to do? Yes, okay, cool. I'm not going to read all of that. So sorry if you're writing documentation, I'm not reading all of that. Then, of course, I had to start like going a bit deeper because sometimes, you know, you got to debug stuff. And I tried to understand things by myself, but that was difficult. So I have a friend that works at Sysdig, and I bugged him, I believe, like once a week for a full year to understand what was going on with eBPF. He's a Falco maintainer. His name is Jason. He's not here today, but because Sysdig didn't want him to be here today. But yeah, he had a problem with the flights. And aside from that, I want to know, well, what do I know about eBPF? Again, I will oversimplify it. It's not going to be a deep dive. I wanted to have a demo, but I thought that was too much because there is another talk coming after that's more like hands-on with eBPF. So I didn't want to like do the same thing. And I want to know how many of you here use eBPF or eBPF-powered tools, which is a bit different. 1, 2, 3, 4. OK, cool, cool. So you're in the right place. This is a 101 eBPF class. So what does my grandma know about eBPF? Which is a fair question, 0, at the beginning of this talk. She knows about cloud computing and Kubernetes, because I had my previous talk was I explained Kubernetes to my grandma. And that's a real story, actually, and this is another real story, too. So my grandma comes up to me, like every Christmas, hey, what are you working on? Kubernetes, blah, blah, blah. I explained to her Kubernetes in a very fun way, talking about food. And she did the same with eBPF. I was working on some observability stuff. I wanted to build like a tool. I co-founded my own company, and we wanted to have our own observability stack embedded in Kubernetes. So yeah, we decided to do our own thing, reinvent the wheel. Don't do that. And so yeah, I was working on eBPF, and she asked me to basically build this talk. So this is the other question that I already had for you. By the way, if someone has a question or like some more technical details, we can discuss them later, because now I have to do some more research on some internals of eBPF. I'm going to explain to you why in a bit. So let's start from the kernel. How many of you know what the kernel is? Okay, some people know. Cool. You're not Java developers, I see. And so the way the kernel works is that it's a bridge between the user processes, or processes, we should say, and the resources underlying. So the operating system can give resources to the processes, and the kernel orchestrates this process. And well, this is kind of the core of the operating system. And to explain to my grandma, I said, it's like a kitchen. Like, it's the core of your operations. And why I say kitchen? Because it's like the kernel. You wouldn't change your whole kitchen, like your appliances, unless it's strictly necessary. And with the kernel, it's a bit of the same. Like, you can have some kernel modules. You can, of course, update your version of the kernel, but it's something that is pretty stable. And you work on top of that. Managing a kitchen is fairly complicated, and it's something where a tool like eBPF could be a game changer. Some of the kernel jobs. So what does the kernel do? Is managing the memory, so keeping track of the memory usage and who is using the memory, so how much and for what. Processes, so orchestrating the time slicing for every CPU process. Drivers and input-output, so whenever you're using like storage or networking pieces, that's when the kernel is acting. syscalls, which is what we're going to focus on with eBPF. So it handles requests from your processes that are connected to something like a file or some specific component of the operating system. Examples of syscalls could be open a file, read a file, kill a process. And to explain to my grandma, I said, well, basically, this is all that, everything that a restaurant manager has to manage. So what is a syscall? If the kitchen is our kernel, a syscall is a waiter. So the waiter is going from the customer, which are our processes, and sending the request to the kitchen. And the kitchen does their thing, they cook, and they bring the plate out. So yeah, this is basically how the interaction, in my head at least, works for eBPF. And what is eBPF again? Okay, this is a cool question. It's a small sandbox VM that can run user space programs, or let's say just programs, in the kernel space, but without writing kernel modules, without altering the kernel, without recompiling everything. And it's extended from BPF, which was born in 1992. And BPF is in the Linux kernel from, I don't remember which version, but a very old one. And now, in simpler words, to explain to my grandma, imagine you're preparing something at the same time of your nephews, and you let them use a smaller portion of this kitchen, like embedded in a sandbox, away from the rest of the dishes that are getting made, so they cannot like use the gas, they cannot like access directly to something. You are giving them a way to safely prepare their things. And now in tech words, let's analyze TCP dump -d comment and how it uses BPF. So there is BPF bytecode generated that goes on here in the kernel space, and it's attached to a network tap. And a network tap is something that can read and monitor the traffic. And this will be run, this code, will be run against any package on the network interface. and only the packages that are matching the filter are going to be passed. It sounds scary to manipulate network traffic like that and to be able to access it. Yes, it is. But we're going to see that eBPF has guardrails in place to avoid disasters and like security issues. Why do we need eBPF? That's a great question. To dynamically and programmatically trace kernel or user space functions and events safely and efficiently. We're going to see why, especially on the efficiently side, because you have to imagine that, I mean, at least the first time I learned about eBPF, I was like, okay, but how is this not slowing down network? Because there's something that's parsing all of these events, and I thought, if that's a filter, I imagined it like an if statement. I still have to go through all the packets, and I still have to like open them, get what's inside, and then pass them through. So that would slow down the thing. But actually, no, they don't do it like that. They do it in a very smart way. And that was me like trying to figure out eBPF the first time that I learned about it. And of course, if you already know most about eBPF, this talk is going to be still very fun for you, so please stay. So in a nutshell, what does eBPF do? It allows to supervise our kitchen, our kernel operations, monitor our chefs, so the processes that are working, and ensure that our guests receive the right dish or the right packages, possibly not poisoned, which is always very good. And this is eBPF under the hood. This is not my grandma, of course. It's a famous meme grandma. I have to look for a picture where my grandma looks like that. I have to buy the sunglasses. So for example, now we can hook our eBPF program to this syscall, exec-v, and do something with it after the program reaches the scheduler, for example. We can trace it. We can log what's happening. But you see that eBPF lies inside of the kernel, and the syscall is our entry point, which is outside, because it's our process calling for, in this case, the scheduler, to understand if they can use the CPU in that moment. In this other example, which is how the eBPF runtime works, by the way, run to the hills, because I always want to put at least one meme inside every slide. The program is connected to a socket, in this case, and it gets triggered by send messages and receive messages. It's like there are two different syscalls. And by the way, these are all in the Linux kernel manual, so if you want to see exactly what they do, you can even go down to the C code. There is actually involved in this process a verifier, which is the guardrail that I was talking about before, which is something that ensures a couple of things. First, that the eBPF program can terminate, so that we don't have infinite loops, because that would be a disaster. That all instructions, especially regarding to memory and memory reads, are valid and within an acceptable range. If you ever work with C or pointers in any other language, you exactly know what I'm talking about. I did that, unfortunately, and I don't do it anymore. Yay. The single BPF program has to have less than, correct me if I'm wrong, 1 million instructions, and that's after kernel version 5.2. I think that's the thing. Before that, it was like less than 4,000 instructions. And for instructions, I mean the instruction resulted from the byte code. So it's not like the lines of code, but it's like even including like loops and stuff, how many like instructions are given at the machine level. There is also a just-in-time compiler. No, this is not like JavaScript. It works in a different way. As the name suggested, it compiles the program at runtime to maintain kernel-native performance. And this is basically how the runtime works. Then we have hooks. This is the most interesting part for me, because at the beginning, I believed that eBPF could only attach itself to a syscall, which made sense. But then I realized, no, it can be attached to the process, can be attached to a socket, to a virtual file system, to the TCP in whichever place, and between the devices and the hardware, so network device and block device, which is really cool. It makes you understand how attaching yourself to a kprobe, which is a kernel function, or uprobe, which is a user space function, in this case, like this process, can allow you to basically input the eBPF program in any point. And since they can communicate between each other, we're going to see that in a bit, you can create very complex programs with eBPF. And aside from that, you can also have the function, the eBPF hook can be at the entrance of a function or at the exit. This is really important, for example, in security. Like you want maybe to block a Cisco that's trying to access a certain file with a certain grade of permissions, and you want to block it at the beginning, so at the entrance, and not at the exit. But maybe if you want to measure the performance of your software, you want to measure more, you want to measure the entrance, like just the time, and at the exit, maybe you want the whole stack trace, and you want to have the whole like memory with your program. We have maps. So yes, you can store stuff in eBPF. You can use a hash table or an array, a ring buffer, a stack trace. It's useful to store, yes, the program state, but also configurations, and you can share data, like in this example, between two different eBPF programs. They write and they read from the same state. And you can even share metrics and stuff with the user space, so outside of the kernel. And that's very useful for observability purposes. Some of our favorite tools, I think for sure Habbo, it uses like this kind of thing. And then we have the helpers. Of course, we need to have some functions that can help us, like generating random numbers, getting the current time, getting a process or a C group context, when we have to, of course, do networking and some more sophisticated stuff. We have to manipulate packets, and maybe we want to forward them somewhere else. Like with Cilium, we do all the routing of the packets with eBPF. And we want to access maybe sockets data, because we can do manipulation at that level too. And these functions are all BPF functions. You see there is no E, because these are like from the old tool, but they're still used in eBPF. You can find them both in the Linux manual and in the eBPF website. So you can check what you can do with this kind of helper. Tail functions and function calls. So picture this. You can chain eBPF programs, and you can kind of keep them readable as far as C program can be readable, even if you can write eBPF code in Go, because there is a library like that converts everything for you. So if you are a gopher like I am, you can do it in Go and hope that the translation goes well. It's pretty cool. It never fails, but I like to keep you guessing. And then you can even reuse functionality within a program, because we like to reuse. We like to recycle. We are all sustainable here. And reduce the overall size of our eBPF programs. That's also like very helpful for the overhead. And this is thanks to the function calls. Now, let's examine how, for example, Cilium, in one of the cases, uses eBPF to capture traffic from pods. So imagine you have your pods in your user space, of course. It's in a cluster. You're using Cilium here. And you have an eBPF probe in the kernel that's connected to your network device. Once the traffic passes, the eBPF probe can then pass the stuff to Cilium. You can manipulate then the packets, do many, many things. You can apply network policies. You can do load balancing, and you can assign them to services. You can do bandwidth management if you need it. You can then, of course, like log the policies to whatever FluentD, this is Elastic, I guess, or in any format that you want. And then, of course, Grafana, Prometheus, you have your metrics. You can do very, very cool things with Cilium. Aside from this, they also have, again, I mentioned Habbo, which is more for observability of your networking stack. Cool. And this is, for example, how Falco uses eBPF. Of course, I attached the logo because I didn't change their schema. This is from SysDig. I didn't want to have copyright problems. So what happens in Falco is they use an eBPF probe to ingest the syscalls, and they don't work the workflow, of course, because even if they do security, they never, unless you configure it in a certain way, they never block the syscall at the origin. They make the data flow in two different libraries they wrote. They are both open source, libscap and libsimp. One captures the dump of the files and every operating system metric, and the other one does the event parsing, filtering, output formatting to put them in a visually appealing way, at least for your observability programs. And this generates events that are then passed to the rule engine of Falco. And if there's anything suspicious regarding the rule engine running in the same moment, you can get an alert. The alert can go to a webhook, to a gRPC service, to Falco Sidekick, which is their UI, or to an exporter on Prometheus, and then you can have your own dashboards. You can attach anything you want to it. You can run comments, or you can just log the calls. And this is everything that you need to know about how eBPF works in Falco. Now, of course, if you want to go deeper, they also have the code open source for their probes. So you can go to Falco Security and check out their code on GitHub. Now, isn't there an alternative to using eBPF? Yes. You write your own kernel module if you want. Go ahead. I never did it. I would be glad to help you out by doing nothing, just laughing at you. So the absolute best, if you can afford the risk of kernel panic, effective, yes, but not efficient. Unless, again, you are a C programmer, you are Linux-star worlds, then you can write your kernel modules. Sidecar, bit of a overhead. Ever heard of that? How many resources you want to waste? Imagine like you have to have a sidecar container for every of your clusters. I don't know how many clusters you manage. I did manage a lot back in the days. No, not anymore because I'm a DevRel. But yeah. Agents. Yes, I always wanted to install an agent every time I run something. How many agents can I afford to install? I have I don't know, my Dynatrace agent, and then I have other agents, and then I have this agent. Oh, God, I forgot one agent, and now anything breaks. So I don't want to manage swarms of microcomponents, so I think eBPF is the best way to do observability, security, bit of everything. I think it's a cool approach. And the proof is that multiple products and multiple vendors are using eBPF, which is, of course, like very open source, and there's no like central entity governing it. And with all this honey, with all these bees, where's the honey? Well, we have a flexible way to work with the kernel, but way less complex, which is very, very cool for me. A performant plug almost anywhere in the network stack, and a small print in terms of resources. Actually, I was very surprised to see that there is no overhead in running eBPF programs, unless, of course, we are talking about like millions and millions of requests, and then probably your problem is not that little eBPF programs, then can be your your whole workload. As my grandma would say, it's like I could be anywhere, anytime, checking that you don't get lost in a glass of water. So this is what eBPF is to me. It's like this grandma that checks that everything is fine, that you're doing your thing. And it's an Italian say, sorry, I can't really translate it. I have no idea if you have a similar say in English. And this is how I explain to my grandma on a napkin what's eBPF. Like you can attach your grandma to the nephew call, and then you have a shopping list, you check the fridge, you buy something that's missing, and you cook the food. And the grandma is like actually checking every stage, ensuring that everything is done in a certain way, in her way, of course, because that's the right way. Disclaimer, no grandma has been mistreated to draw this schema. She wanted it. And before you go, there's another cool eBPF talk coming after this one in the main stage. integrating eBPF superpowers into your observability tooling. So if you now understood a bit better eBPF, you can go to that one with some more tools in your bag. Thank you for attending. The slides are from Slides Carnival. I am terrible at graphics, so that's not me. And eBPF.io for every information that I use in the presentation. That documentation is pretty neat. This is one of the few times that I read the whole documentation. And I'm Bianchi Dev on any social media, including Blue Sky. Thank you.
Questions? Anybody? Okay.
I'm afraid.
Go for it.
So this was a really nice introduction to what eBPF is. My question is like, okay, so what if I want to write an eBPF program? How do I do that?
So you have to be a C programmer, or you have to use that Golang library that I told you about. And the thing is, on eBPF.io, you have a lot of examples. I didn't include those because I didn't want to like do the same thing. So you can read about, for example, how you can attach the eBPF probe to learn about the footprint of your program. Like that's a simple example. You can just guess, you can just attach it to the syscall, understand like what are the resources used by your program, and you print them, and that's like an hello world in eBPF. I actually think it's not open source yet, but I have a repository with some eBPF programs that I did in the past. So I can open source it. Actually would have been a good idea, but I didn't have time. So if you follow me on GitHub, you can find it, I think, 1-2 weeks from now. That would be.
Thank you. Totally not related to your talk.
Okay.
What's the name of the band?
Of the band?
Yeah.
Scapegoat.
Scapegoat?
Yes.
Thank you.
Yeah.
Anybody else? We have 3 more minutes for questions.
And actually, I have to add something. It's Scapegoat NL, because there is another Scapegoat band in another country. I don't remember which, so we have to distinguish by country. Copyright issues. It's like CNCF underscore the region.
Yeah? Okay.
Thanks. In terms of the use cases for
Yes.
eBPF, which ones do you think are the most valuable and the most like differentiated from other tools that you think are like unique to eBPF? And
Yes.
yeah.
That's a great question. So I think runtime security is one of those, because in security, what you want to do is to have the complete access at the lowest level. And to be at the lowest level, you have to be at the kernel level. And that's very complicated. So unless you want to write kernel modules, which you can do, you can even write kernel probes yourself. But if you want to do it in a simpler way and in a way that has a framework around it and a community, I think that's the best way to do that. And then networking, there are some solutions that are different. Like Istio used to have only the sidecar thing. And now recently, I think they have a sidecar-less Istio going on. Even for open source. I think eBPF has this thing where the performance you get is way better than a sidecar in comparison. And with a sidecar, you have more overhead, you have to maintain them. With eBPF, you don't have to maintain anything. You're just injecting it in the kernel. So you don't need to have anything running in your infrastructure. And it's nothing in particular, like it's not like an agent that you have to install and remember about it. And again, maintaining the version, updating it. So I think these are the 2 cases that I found more compelling. And that's why I use Cilium and Falco. Cilium actually also does security, but I think Falco is slightly better in that case. And I'm not related to any of these companies, so no Isovalent, no Sysdig for me. So this is purely open source. It's my opinion. If you want to send some folks from those companies to talk to me, feel free to do that. I would love to.
Anybody else? We have time for one more. Going once? Yeah.
Yeah. You gotta offer me a beer after.
Yeah, sure. This is maybe a follow-on to that question. Do you think there are opportunities for using eBPF kind of outside the realm of observability and security?
Ooh.
Like, could we write a kubelet in eBPF or a scheduler in eBPF or something?
So, since you mentioned the scheduler, I would say yes, why not? like we could try, especially since, well, the fact that they do their routing like during networking, and that's very fast and performant, we could think of doing the same for a scheduler. Before my talk, Justin Garrison did a very interesting talk on orchestrators, and how the scheduler in some of the orchestrators used to like shard the API server, and I think in this case we could use eBPF to do the routing of requests to those shards in an efficient way. This is just one idea that I have right now, but it could be many, many things. Like its power, it's mostly to be at the very low level in the kernel. So anything that needs to be very performant, like even edge. You want to do something at the edge, probably low resource usage, eBPF is a good choice. Now, I don't think there are, or maybe that I know of, projects exploring these possibilities, but why not? We can try. If you are a C programmer, we can try.
Okay, you're out of time. Go
Thank
ahead.
you.